Hello, it's Dr. Lou. In case you have not watched the prior videos, I am the lead faculty member who has created the online laboratory classes using kits from Science Interactive. In today's video, I'm going to review how to complete the tables for naming ionic and molecular compounds. Today, we are naming ionic and molecular compounds. Before we get started, I want to review what is an ionic compound, what happens to be a covalent molecule, and what is the definition for an acid. So let us start with ionic compounds. So what do ionic compounds have? They have two ions. They have a cation and then an ion. So the cation is going to be positively charged. The anion is going to be what? Negatively charged. The cation will almost always be a metal, so the cation will be a what? Metal or a ammonium, and the anion will be a non-metal or polyatomic ion. Okay. Those are ionic compounds. So now let's define covalent compounds. So covalent compounds or molecules, they will have two or more non-metals. And if you are looking at the name, we use the prefixes when naming them. Okay, last category are acids. Acids. So acids are covalent molecules in water, meaning when we write the formula, we will see a Q. Another way to know that we have an acid is in the name, we will see acid at the end. Okay. So, few things to keep in mind. When we are going through this lab, we always want to use the systematic name for naming the compound and molecules. Most compounds and molecules have common names that are not the systematic name. The name you will be required to use on a lecture or laboratory test will be the systematic name. Therefore, if we have a transition metal, we want to use Roman numerals. We do not want to use the Latin names to indicate the oxidation states. Rather, the oxidation states or charge should be indicated with Roman numerals. For covalent molecules, we want to use prefixes rather than the common name. So, I want to give you a little bit of practice with naming compound and providing the formulas the way they are going to be in the data tables for this experiment. Okay, so let us practice. So I'm going to give us a compound. So let's say we have S. Whoops, it disappeared. Wonder what happened. We have SO3. Okay, if we were given the formula SO3, we know that SO3 contains no metals. So this is a covalent molecule. Now we want to go about naming. The element S is sulfur. We have 3 what? Oxygens. So we're going to use tri. And then we'll use oxide. So when naming covalent molecules, we pretend that the second element is what? A non-metal, and non-metal ion, I should say anion, and we give the ending what? Ide to it. Okay, let us try another one. And let's see. Okay, so this next compound or molecule, let me bring this down just a little bit. We should see it is made up of 2 parts. The 2 parts are going to be an Mg 2 plus and NO2 minus. Because we have these 2 parts of the molecule, these 2 ions, we are going to have something that is what? Ionic. So when we have something that is ionic, unlike a covalent molecule, we do not use the prefixes. So the first element is magnesium. And let's see if I can move that magnesium over, whoops, just a little bit. There we go. So now we have magnesium, and what is next? We're going to have nitrite. Make sense? Okay, next. If we were given HBr with AQ at the end, the AQ at the end is telling us what? We have an acid. So acids are covalent, dissolved in water. So this would be hydrobromic acid. Okay. So now what we want to do is look at going the opposite. So we can erase. And we're going to now look at names, and we're going to go to formulas. So if I were to write, for example, chromium IV nitride, what does the Roman numeral 4 tell us? The Roman numeral 4 is going to tell us the charge of the chromium. So we have Cr 4 plus. And now for nitride, it is in group 5 of the periodic table. You need to commit to memory group 5. It would be N what? 3 minus. So as a review from lecture, all compounds must be neutral. So we have so many chromium 4 plus so many nitride, which is a 3 minus, must equal to a 0. It should be obvious that x is going to equal to a 3, y is going to equal to a 4. So again, we did this arithmetic because we have 2 ions. So this compound is ionic. The formula is Cr3n with a 4. Hopefully that makes sense to everybody. So now let's look at sulfur dioxide. When we have a covalent molecule and there is no prefix in the beginning, we understand the omitted prefix mono. So there is 1 sulfur and there are 2 oxygens. So this is covalent. And we have SO2. Finally, let's look at an acid. So if we have hydroiodic acid, hydro means H, iodic means I. This is a covalent and the formula is HI, and because it is an acid, we should use aqueous. I believe I have gone through how to complete the data tables. We will have 4 tables to practice. In the first 2 data tables, you will be giving me either the formula or the name of the compounds, as well as if they are ionic or covalent. In the last 2 tables, you will only be providing the name or the formula. Remember, if the name or the formula is of only a polyatomic ion, we have to give the charges.